Hello everyone, welcome back. So let's understand in this video this question that we have today. Okay, so I have already uploaded the first part of video where I have discussed about how to do in the approach, right? But I forget to do the dry run, and so I am thinking to let's prepare the from the scratch a very good video, so people will like. I think this is a very important question to understand how to reschedule the meeting for maximum free time, right? So what the question is saying, that the question is saying that we have given a event time. Let's call the time we have given means from here to here you have a working hour, means from 0 1 2 3 4 5. This is a event time. Okay, where these are the meetings we have given, a start time and end time. So start time saying is 1 and 3, right? And end time is saying we have 2 and 5, right? It means the first meeting is this and the second meeting is this. Means meeting M1 call M0 we can say that, and this is M1. So meeting M0 is start at where? At 1 and ends at 2. Meeting 2 starts at 3, ends at 5. Can we say that? We can say that. And you can see this is your M1 and this is your M2. So but if you observe that the given things, let's suppose we have given what? 0 1 2 3 4 and 5. So if you'll put this one, where is M1? M1 is between 1 and 2, right? So we can say between here to here is M1, right? And M1 M1 is, this is M0, meeting 1, and meeting 2, that is M1, is from 3 to 5. So what is the free time? So free time, we can say this is your free time and this is your free time, right? But we have to use the given K, right, in such a way we can reschedule at least K meetings. We have to rearrange the meeting. How many times? At most K times, we can say. Okay, so let's suppose there is a chance that we are going to reschedule the meeting. How we are going to reschedule? Let's suppose the very first meeting is we have M0. So this meeting, if we will shift from here, give me 1 second, if we will shift from here and will move into here, so it will look like how? Now give me 1 second. So it will look like how? Can we take this one? Okay, so let's suppose now this will become 0 1 2 3 4 and 5. This is your 5. Okay, so now your free time is from where to where? We have started, we have shifted this M1 to here, right? Means from here to the 5, right, are occupied. These are occupied. So we can say from here to here you are occupied. This line, this line, this line, you're occupied. From 2 to 5 you are occupied. Okay, so what are the free time are there? Only here and here. So how many meeting? You don't have any meeting, means you don't have meeting at during 0 to 2, and 0 to 2 have 1 unit is here and 1 unit is here. So total how many unit is there? 2 unit is free. Can we say that? And that is why if you see the answer is coming 2. Okay, I hope you understands. Okay, so let's continue. So let me tell you something about this problem, right? Problem statement. So what this problem statement is saying that okay, so let me tell you about this problem, right? What problem is saying, right? So we have given event time we have given, right? Then we have given K, we have given start time and end time. These 4 things we have given, right? So this event time is the total time of the day from 0 to the event time that we have seen, from 0 to the event time. Can we say that? So this is we have given from here to here total. as you can see is 5. Means if you count this from here to here, total unit is 5. So total time of the day we have given from 0 to time. Now let's talk about the event that starts, right? So start and end are very important here. So start and end, we have n non-overlapping meetings. That is not overlapping, means it is not crossing each other like this. Can we say that? It's not overlapping, right? Means we have given 1, 2 and 3, 5. As you can see, there is no overlapping between them. If this is M0, if this is M1, they are not overlapping each other, as you can see in this picture also. Can we say that? So these things we have given. Now understand, we can reschedule this meeting at most how many times? K equal to 1, means K at least you can say we have to reschedule at most K meetings here, right? In this means number of meeting is 1 meeting. In this case we can reschedule maximum by either moving their start time, right, earlier, we can say that. So the duration is fixed, right? Order preserve and inside the bounds we can say these things are preserved. So what is our goal? Our goal is to after reschedule we have to maximize the longest continuous free time during the day. Longest, what is the longest continuous? As you can see, right, means we have the continuous we have found 0 to 1 and 1 to 2 was free. After 2 to 3 the till the 5, right, means 3, 5, 3 and 5, right? So this time we have meeting, this time we have meeting, but this is your free time. Means after rescheduling, the maximum longest continuous free time during the day we have to find. I hope you understand, right? So to solve this problem, right, to solve this problem we have to reschedule the meeting for maximum free time, right, using the, you can say we can use a greedy plus sliding window approach. So these two things, greedy and sliding window approach, we will use to solve this problem, right? So if you have already gone through my video, I have already uploaded the code, right? That we'll discuss more in this video because we'll do have try run this will also. So let's understand what are the observations we have in this video, okay, in this question. So the question's observation is like we have meetings are non-overlapping, right? And it's in the order. If meeting M0 is coming first before the M1, right? So this should always, if you're rescheduling, it should be in the order only, right? You cannot do M1 first and then M2, sorry, M0. No, this is, you cannot do, because this order should be preserved, okay? As well as it should not overlap each other like this. M0 is here and then M1 start from here. No, it should be independent. There should be, if the end time is finishing, after that you can start. I hope you understand, right? Means meetings are non-overlap and order. And then we can shift how many meetings, K meetings, to start earlier, right? We can do, because we have to also think about that it should be, the meeting should be in the valid, the order should be valid. So we can't change the duration and we cannot do reordering meetings. Understand? So what is the maximum free time appears, that we have to find out. We have to find the maximum free time that appears between these meetings, right, at the start or end of the day. Either you, let's suppose you are putting let's say this we cannot put here, right, because if we will put here, let's suppose, then we have to shift this one also this side. So that is not possible because the K is 1. Can we say that? We can shift this one anywhere, but if there is one more is there, let's suppose here, so this is only 1 unit, but this is 2 unit. The 2 unit cannot go to the 1 unit. I hope you understand, right? This is thing. As you can see in the picture also, right? We cannot shift the yellow one and here because it will not fit, but we can fit this in this position as we have done, right? Now think that the intuition, you can say. What is the intuition, right? Means we have to maximize the free time and we can pick a window of K consecutive meetings, right? We have to take a window of k consecutive meetings, right? So to maximize the amount of free time, right, what we need to do, we have to pick a window of k consecutive meetings. Can we say that? Let's suppose in this case, if k is 2, let's suppose k is 2, it means we have to take the window of how many meetings, consecutive k meetings, we can say that, right? So let's suppose if k is 2, it means we have to pick both of them, right? Or you can say we can take this meeting and this meeting too, and we can pick this window, we can say that, right? So that we have to understand, right? Means very first we have to pick the window k consecutive meetings we have to take, and then what we need to do, we have to push them as early as much possible. Where? In the left side, right? That is called greedy, you can say, left shift. Can we say that? If we'll take this window, how many window? K consecutive window, let's suppose, and we'll put we will put left side. Let's suppose in this case we are putting this side, right? So and you can put this side also, but the possibility is there, what we can take this side also, here we can put, here also you can, from 0 to 1 we can put, right? And from 1 to 3 you are free, you can take here and here. Can we say that? We can say that, right? So we will put in the left side, let's suppose, what I'm saying. So first we have to take how many, what is the window we have to do? We have to pick a window of k consecutive meetings, means k is 1 here. So let's suppose if we'll take this and we'll put here, that we have done here this side, right? So it was free. Let's suppose this time we'll put here, means it will come out 0, 1, 2, 3, 4 and 5 we have, right? Means if we will put here, so it will become what? This will be our window, correct? That is called M0. Can we say that? And this window is already occupied, right? Where 2 unit is already there. So this is our M1. So what are the free units are there? Can we say that this is our free unit 1 and 2? 2 unit is free. So we can say that. So what we can say in the intuition, that we will pick a window of k consecutive meetings. K consecutive meetings we will pick, right? And we'll push them earlier as much as possible, right? Means from here to here we'll push, right, in this side, right? And that is called our greedy shift, right? That is why I am saying we'll use greedy plus what we call sliding window, right? Sliding window, right? So greedily what we will do, we'll slide in the left side. Then what we should do, let's say left side, okay, we'll push. Then what we need to do, then we will open a larger free gap. As you can see, this is our larger free gap. Can we say that? So before the window, after the window. So before the window is possible, and before the window is this one, okay, and after the window. Can we say that? Or in between. Can we say that? So these are the possibility that we may open a larger free gap either before, after or between. That is why I said the previously that we can shift this side, right? This side I told you, and now I am saying we can push this side also. So possibility is that you can free up the size either the before this side or after this side of the given window, you can say, or in between also. So for each window of k meetings, we can say, will compute free time. So let's understand how we are going to find the free time. Give me 1 second. So let's suppose if we have the free time, we have to find. How we are going to find? So let's call free time. How you are going to find the free time? Give me 1 second, guys. Okay. So free time that we are going to find is the time between the adjacent meeting. Can we say that? time between adjacent meeting minus we will do what? Total duration. Total duration of k meetings. Can we say that? So the time between adjacent meeting, what is the time between the adjacent meeting? That we will take whole, means this meeting, this we will, if we'll take total is become what? 5. Now it is taking how much? 1 unit, 2 unit, 3 unit. So the total it is taking how much? Is 3 unit. So how many left? 2 is left. So this is your free time. So like this we have to do. We have to find the window of k consecutive. Then we have to find what? We have to push them into left side, that is greedily will shift this side, right? And then it may open the space either this side, right, or in between the window, right? And you can find the window meetings, right? The free time, we can say. So let's understand the approach that we are going to use. So we are going to use the greedy approach, right? As we have told, right? We'll use the greedy approach and the sliding window approach we are going to use. Means we want to iterate I from 0 to n minus 1 meetings, right? Means the number of meetings. How many meetings we have given? M0 and M1. Can we say that? These two meetings we have given. So if we'll take the size of this meeting, what is called n equal to 2. Can we say that? It means I we will start from 0 to 1. So for 0 means meeting M0 and for 1 means M1. So this meeting will go. We'll iterate over this meeting. So we have to track the total T of current window K meetings, we can say. Means we have to track the total duration. That is called T. Right? Means we have to find the T of the current window of K meetings. How many meetings? 1 meetings, we can say, right? How we are going to do that? So for each I will compute like this. Let's suppose call left means end time at I minus K. So what we have given in this case? We have given two things. We have given meeting 1. Let's suppose I'll clean this. So let's suppose meeting first we have given is from 1 to 2. This is given. Let me check. So it is given 1, 3 and 2, 5, right? Means let me write again here. Means the meeting is start from where? At 0, 1, 2, 3, 4, 5. Can we say that? So very first meeting M1 was at here, right? That is called M0, and another meeting will starts from here to here. That is called M1. Can we say that? And we know that I will go from 0 to 1. Can we say that? So we have to find the total duration, that is called T of the current window, and current window size K means K meetings. K meeting is 1, means 1 meeting. We have to find the current durations. Okay, how? So left at n duration, right? So and so very first we have given is two things we have given, right? The start time we have given 1 and 3. Can we say that? Means a start time is at 1 is for meeting 1, start is here, and meeting 2 we have here, correct? And then we have end time we have given is for meeting 1 it's 2, and end time we have given is 5. Can we say that? Two things we have given, right? Now we have to go in which directions? We have to find the left first, right? So left will become at I minus K. What is I? When I is 0. When I is 0, we will find the time. So end time is here, let's suppose. So I is 0 minus 1. It become what? Minus 1, right? So if left is minus 1, if the window start after 0, else return 0, right? But here I is what we have is we have minus 1 we are getting at the end time. So we do not have anything like this, right? So left will become, let's suppose we'll take 0 in elsewhere. If the window starts after 0 is fine, otherwise it will be 0. So this value left will be at 0. Can we say that? So give me 1 second. So here we'll take left, and left will be at 0. Now we are going to find the right. Right will be at start I plus 1. So I is 0 plus 1 means 0 plus 1 is 1. Means we are going to find this one. Can we say that? So your right is, in this case, is 3. Right? If the window ends before last, right? If the window, so what is the window we have? From 0 to 3, right? From 0 to 3 we can take, from here to here. This is our window. 0 to 3. Give me another color, we should check. Yeah. So this is our window from here to here, current window. Can we say that? Okay. So this is your window from here to here when I is 0. Okay. So this window we are talking about, what is the window? This is our window. Else end time will be what? We have to find the event time. Else will be end time. Means if the window ends before the last, right? Correct. So the window is at 3, so it's fine. Otherwise we'll put the window at here, this point. So the gap is become what? Right minus left minus 1. Can we say that? Let's find the gap. So gap here, it will become what? Means we have right is at where? 3. Left is at what? 0. And time t we have is initially it's also 0. Can we say that? So total it become what? 3. The gap is 3. Now one thing we have done mistake here is for the t, this will come 1. Why? Let me tell you how. So when we are finding the total duration t, right? We have not written here. That is our mistake. Means how we are going to find the t? So we'll take t when I is 0, right? We'll take t plus how we are going to track, right? Means we have to find end time at, we can say I, let's suppose. Can we say that? Minus start time at I. So what is the how we are going to find the t here in this case? Let's suppose t we have not found, so let's find the t. So t, I told you initially it was 0, right? So when t is, it was 0, so we are going to do plus. So end time at I means we are talking about 0. So what is end time? We have is 3. Now have a start time at I. What is the start time we have? No, end time is 3 we have here. Okay, end time is not 3, sorry, what I'm doing. Okay, so we can say 5, right? End time at 0 is 2. This is 2, right? This is 0 and this is 1. This is for end time. I'm seeing here. Okay, so end time at 0 we call it what? 2. Can we say that? We can say that, right? 2. Now start time, think what is the start time at I? Start time I is 0, so this is 0 and this is 1, right? Means we have to find this one also, right? So we'll do minus 1, so it will become what? 1. Okay, so you will put here, what will come? It will come 2. So now if you find the gap, this gap will come is 2. I hope you understand, right? Now we have to update the result with max and res. So res nothing but our result. So initially it will be 0 and the gap is this coming is 2. So what will come? Between the 0 and 2, what will come? The max is coming 2. Like that you have to track it, right? And then you have to update it, right? So let's understand the what we call the code, then we can understand. So this is the piece of code that I use while understanding, right? Let me show you here. Let me check. Go with the red color itself. Okay, red we have here already. I'll go with this color only. Let's leave it. So we have this code, right? So free time we have given, where we have to take what, end time, k, start, and this. So end time we have is 5, k we have given is 1, and a start time is given 1 3, and this is our end time. Can we say that these things we have given? So when we are talking about meetings, we have two meetings, we have 1 2 and 3 5, right? Here starting we have we have taken t equal to 0 and res is 0. So this is our res, right? And this is our n that we know, right? Can we say that? Let me clean as well to here. So this is our res and this is our n, right? We have to find. So you know the start time dot length will get how many? Will get 2, correct? As we have seen. And res 0. This is our t, means total duration of the window, that we have to keep track of that, right? And then we have this for loop. So this for loop will continue. We have to iterate over that. I told you, right? We have to iterate over these meetings, right? So I is 0 and I is less than n, then we also I plus plus, right? Like that we have to do, and you have to find the t, right? How we are going to find the t? So t is 2 minus 1. We are getting what? This one, right? 2 minus 1 is 1, correct? And we got the t here, 1. Then similarly we'll find this. We are talking about when I is 0, right? So for the meeting, this one m1, so we'll get left 0, and so we will, if we'll check this, these are the conditions that we will check, okay? Then left will become at 0 and right we will find at 3. So what is the max we will get? So res will get 2 here, as we have discussed, right? And then you will get I is greater than or equal to k minus 1, means we have to subtract the duration, right? So total, if you see, we are getting the duration, and finally we'll find what? T is 0, means we are on track, so no problem, right? So first what we need to do, give me 1 second. Very first we'll go for I is 0, we'll track the t, and t will become what? At 1. Then we will find the left, as we see 0. Then we'll find what? T is at right, and we have seen how to find this t, right? So once you both have, you just do you find the gap. How we are going to find the gap? Right minus left minus t, right? And you will find the gap, so you will get the result. And then we will do what? I should be greater than or equal to k minus 1, and we'll find what? This time, right? If t is this one, so you have to find the oldest meeting time, right? You have to slide the window, and we have to remove the oldest meeting times from here, and then we'll return res. Okay, similarly when I is equal to 1, we'll continue this one and we'll find the answer. So we can say, if we have given this k, we have given end time, we have given k, we have given start time, we have given end time, we have given, right? Means what is our goal? Our goal is to reschedule the meeting, right? And we have to find the longest consecutive free time during this event, right? Means if this is the meeting we have given, right? Let's suppose we have given this meeting, right? So here we was free, right? And here we was free, right? Rest of the thing meeting was occupied between 1 and 2, and 3 to 5 we have occupied, right? So if we will shift the how many meetings? K minus 1 meetings, k meetings, right? At least. So if we'll shift this one, right? Let's suppose we'll shift in this direction, okay? From here to, if we'll shift this direction, right? So we'll get shifted here, and this is our window that we will free. So this is 1 unit and this is 1 unit, so total is 2 unit. We are getting from 1 to 3 we are free. So this is our current a free unit, right? Where we are getting 2 unit max. Now understand, when we have another options, right? When we have given this one, right? And we are not going to shift in this direction, right? We are going to shift from here to here, right? So if this is the meeting we have, we are not going to shift this, but we are going to shift in this direction, okay? Means not left, we are going to right. It means if we'll see the occupied, right? We are seeing from this will get occupied, right? Because we have shifted this one in this direction, okay? So we got this direction like this. Means you can think about that, right? How we are going to shift it, okay? So if you shift this one, so from here to here you will get the occupied, right? And free space you are getting this one. But in this case, if you find the max, you will get 1 unit only, right? And that is why your max free time is not minimum, not should be the minimum, it should be the maximum consecutive free time that you can find. It means if I'll summarize this, let's suppose the shifted meetings we have given, let's suppose the shifted meeting we have, right? And if you'll take a shifted meeting is 0, right? And we are shifting from what? This one, 0 meeting. And then we have M1 shifting what? 2. So if we shift M0, right, and we shift to this one, so M0 time become what? 0 and 1. Can we say that? If we shift it from 0 and this is 1, then we shift 1 and 2. Let's suppose these are the possible time. So M1 time is we're getting 3 5 here, correct? And here we are getting what? 2 4 we have seen, correct? So the largest gap is we got from here 1 to 3. 1 to 3 we were free, right? And here we are getting how many unit? 2 unit. But here we were getting what? Free, as you can see here, 4 to 5, right? 4 to 5 we are free here, and so you are getting 1 unit, right? So if you see, the maximum free time is between 1 to 3 is there. So we'll say the best possible free time is 2, these 2, and not we are going to consider this one. So I hope you will like this video. Let me know in the comment section that you have understood or not. Anyways, thank you for watching this video. And I saw the comment, one of the comment, and I thought, let me modify the video, right? And I hope you will enjoy this video, you will understand this video, and please do support Expert Honda by doing subscribe and like. Thank you for watching this video.